Hello everyone, my name is Ben Alepko and welcome to Unreal Engine Quick Start for VFX artists and linear content. So I want to make this video to help VFX artists bridge their existing 3D and computer graphics knowledge in Unreal Engine. So you could start creating instead of spending hours trying to figure out some of the basic or core principles of the engine. So the goals and outcomes: to transfer existing VFX knowledge into UE5, right? 3D models, shot workflows, scene files, things like that. I want to give you these essential skills because you already have some experience in 3D and I want you to quickly start creating content in Unreal Engine. I'm also going to give you some of the very common terminology and workflows that is different from traditional VFX. And hopefully this will reduce your fear of starting Unreal Engine because you'll have some knowledge to dig from. So now that you know what to expect from this video, I want to introduce myself. My name is Ben Alepko. I'm an Unreal authorized instructor. I'm an expert in utilizing Unreal Engine for linear content, and I have 15 years of experience working in the visual effects industry on feature film and high-end TV. I also really enjoy teaching and mentoring the younger generation. So there aren't any hard prerequisites for this video, but the whole video is based on trying to transfer your existing knowledge of 3D to Unreal Engine. So if you have experience using Blender or Houdini or Maya, that would be very helpful. And if you have experience working in maybe a studio and are familiar with shot structures, that would be helpful as well. Because that's what we're going to be kind of talking about, is how to do some of the 3D basics in Unreal and kind of create and render shots. So we're going to start talking about assets, right? Like asset files on disk, right? On this slide, I have kind of like a comparison between what asset files are in VFX and what they are in Unreal, right? To help you bridge that gap. So if you're talking to someone from the Unreal department or an Unreal artist, you can speak the same language, right? So in VFX, assets kind of live in the file system, right? And they are usually tracked through some sort of a proprietary asset browser. Depending on your studio, maybe you don't really have an asset browser. Some of the bigger studios do. And very common for studios to have multiple software connected to that single asset browser software, right? So you can import assets, the same asset into Maya, into Houdini, into Blender, whatever, right? And publish as well. From Houdini, you could publish back into the asset browser, whatever you create. Now, Unreal sort of comes with something that resembles an asset browser, and it's called the content browser. And your asset files from the file system are imported into the Unreal Engine project. And the project, or Unreal Engine, creates a representation of that file called a U asset, right? A .u asset file. And now that asset lives in the Unreal project. So in a lot of software in the visual effects industry, like Houdini, for example, assets are referenced into your scene file, right? So you're not just directly importing them and are saving them in the scene file. They are just being referenced from somewhere on the file system. But with Unreal Engine, you have to import those assets into your project. And so that project will grow in size the more assets you import. Does that make sense? So when we're working, when we're using Unreal Engine for linear content, it's sometimes common to split up your project into multiple projects for different sequences instead of having one big project for the whole show, because they could grow very large in size and they could take a long time for people to update on their machines. So hopefully that makes sense. We will talk a little more about UE projects and scene files and what is the representation of a scene file in Unreal. But for now, we're just going to move on to talking about assets and asset files a bit more. So I mentioned something called the content browser in Unreal, right? The content browser contains all the files in your project. The source files, after they're imported, they're untouched, right? So you have kind of a copy in Unreal Engine, and you can make edits to it that you want. And some really common asset types, is a static mesh, skeletal mesh, material instance, texture, and Magger system. And we're going to go over some of these in detail. So let's jump into Unreal Engine now and take a look. So this is the default Unreal Engine layout, right? On the bottom left corner, you'll see something here called the content drawer, right? So this is the content browser. By default, it's kind of like hidden. And if I click back on my viewport, it goes away and it hides. So for this demo purpose, I'm going to click this dock and layout button, and now it's just part of my UI. So this kind of used to be the old layout of Unreal Engine, and they updated it to kind of hide the content drawer. So, all right, we have here our content folder, which is the main folder for our Unreal Engine project. And here we have different folders with all our assets. So our content browser also has different filters that we can enable. So let's say I have a filter for static mesh. I could see the static meshes that are in this specific folder, right? Let's see, do we have any other ones? Yeah, we have some other ones. And static meshes, geometry. We'll go over this in a second. So after an asset is imported, we could just drag it into our level. And now we have this, our asset is showing up in the outliner. Pretty simple, right? We could also, duplicate them or drag another one from the content browser and have as many as we want. And so what this filter does, it just, instead of showing me folders and directories, this will just show me all the static mesh type of assets that are imported into my project. Right. So to import something, you could create a folder, or you could be in your content folder. If you don't want to be tidy, you could drag an FBX file in here, for example. You'll have some settings that you can change when importing. And here, look at it automatically created a material instance and the static mesh asset. So I could just bring the static mesh asset in here, right? It's a book. The material isn't really working, but it tried to automatically create a material and try to and assigned it to the asset. Okay, so pretty straightforward. Just to recap, assets are imported into your Unreal Engine project, right? What we're seeing is our Unreal Engine project. And after they're imported, then you could use them and manipulate them. You can even do some modeling modifications, UV modifications, rig them, etc. So next I want to talk about the common types of assets, right? In VFX, we have something, we call it geometry, right? 3D geometry, like a cube. That would be our geometry, our non-deforming geometry, for example. In Unreal, a static object like a cube is or 3D geometry is called a static mesh, right? Right, we could see here, maybe you could see here, let's see, it says static mesh, right? This little blue line, and we could have a filter, right? Static mesh. That's our 3D non-deforming, non-rigged geometry. Then in VFX, right, we have a rigged asset like a character, for example. How do you define that in Unreal? In Unreal, the equivalent of that is called the skeletal mesh, right? So again, we can, let's see, go in here. We have skeletal mesh filter. By default, Unreal Engine can come with this mannequin, and this mannequin character is rigged, right? So it's a skeletal mesh. So I could double click on this, and it will open the asset to give me some details about it. And on the top right, I have a skeleton icon. So you could click on that. It actually swapped the model for me. But the skeletal asset is just the bones. All right, so this is a preview mesh that we're seeing, the mesh of the mannequin. But on the left here, right, we see the skeleton, right? So all the joints and stuff. So I could go to this eyeball icon, bones, all hierarchy, right? So this is the skeleton of the character. And we could see it opened a different tab, right? This is the skeleton. This is the skeletal mesh. All right, so the 3D geometry that's bound to, that's skinned to the character. All right, next we have materials, right? In VFX, we have something maybe called a look def file or material shader, right? In Unreal, we have a material and a material instance. So let's again enable our filter for material, for example. And then we could go to all filters, and under material, we do material instance as well. So I'm going to scroll down. I'm going to click on this material instance called prototype grid gray. And we get just this. We can see our shader ball. We have parameters on here, right? These are something exposed by whoever created the material, right? We can see that this changes our grid pattern size. And then we could go to our parent material. And this is going to be something you're more used to, right? We could actually see the shader graph, right? This is our material, and this is the material instance. And so what is the material instance? The material instance is essentially like a user-friendly copy of the material. So you could see that we have the grid size exposed as a user parameter here, right? So I can duplicate this material instance, and I could say this is grid size 200, just as an example, right? And here, my grid properties, right? The grid size is 200. I could save this one, and this one is our default 100, right? So now I could use these two different material instances on two different assets, right? So let's select the cylinder that we have, and we could drag it into this material property here. You could even just drag it on into the viewport. And so, and then this one will use our default material instance, right? So now these two assets are using two different material instances, but they are connected to the same material. So if we make changes in this material, these changes will propagate to all the material instances that use them, right? So it's very handy, right? You can make adjustments to make materials look unique, but they're all connected to the same material. And that is what we call the material instance. Now, next we have effects assets, right? And effects assets, there's so many things, right? There's particles, there's volumetrics like VDBs, there's rigid body, hard surface destruction, there's deforming assets, right? In Unreal Engine, we have something called a Niagara system, right? Let's see as well, do we have any Niagara systems that come with the content? Yes, we do. So we have this confetti system. We could just drag it out here. Doesn't look like it's doing anything. Maybe, oh, I gotta enable this. So we have real-time viewport. Very cool. So we have things moving. I'm just gonna delete them so they're not distracting. So the Niagara system can have can render different things. It can render particles. It can render 2D sprites, right? So just cards with textures on there, or flipbooks, animated cards. It can do meshes. So it could instance a mesh, a static mesh, 3D geometry on the particle. There's also a volume renderer, so it could Unreal Engine has their own kind of like volumetric system. But you could also import VDBs into Unreal, right? And you could do deforming simulations as well. But a deforming geometry would be called a geometry cache. So let's say if I have an Olympic file, and that Olympic file deforms, and I import it into Unreal, it will import that as a geometry cache file, which is very common, right, in the VFX workflow. A lot of our characters and things are exported as Olympic caches, so there's possibly an Olympic file per frame, or maybe it's just a single Olympic file that contains all the frames. So this isn't a very efficient format to use in Unreal, and oftentimes we use FBX files, and we skin and rig if it's a character, right? Okay, great. So that was a very fast overview of the most common asset types in Unreal and common terminology. So now if someone says, I have a static mesh in Unreal, you know exactly what they mean. Or if I have a skeletal mesh, you'll know exactly what they mean. So let's talk about a concept of scene files, right? So a scene file in VFX is a file that contains your work scene for a shot, for example, right? The assets that you import into the scene file are referenced in the scene file, and usually there's a single artist that works in a scene file, right? And if there's multiple artists working on the same shot, maybe there's multiple effects artists making simulations, each artist will have their own scene file that's unique to them. They could have multiple scene files, one for different types of simulations, for example, or lighting artists have different scene files for maybe they're lighting different assets, different environments. Who knows? In Unreal, there isn't really a concept of a scene file, right? Like I mentioned, there's the Unreal Engine project and everything is imported into it, right? So let's say you're working on an environment, some cave, for example. All the geometry of the rocks and the cliffs is imported in there. The materials, the textures, is all imported into that Unreal project, right? And if you have multiple artists working on this sequence, this cave sequence, everyone is going to be working on that same project using something called source control. If you're working just alone, you don't really need to worry about this. You're not going to be using source control, but source control is a way for multiple artists to work on the same project and not trip over each other's work. So someone could check out an asset, meaning they have it locked to them. They can make an update, upload it to the central server, and then everyone can update their Unreal Engine projects or projects that are local to their machine, right? So everyone, all the artists working on this project, they sync from the server. So everyone has the same versions. And every time you make an update to an asset and you check it back, you check it in, then it will be available for all other artists to upload, to import. So there isn't really a concept of a scene file per se. There's things called levels and level sequences, which kind of resemble a scene file, you could say. But because assets are kind of like saved in Unreal Engine, there isn't necessarily a need for a scene file per se. So what are levels, right? Let's go back to Unreal. We'll turn off our filter. And let's use the level filter here. So we actually have some default levels that came with the template I imported, or I made the project from. And we actually, this is a level 2. Right now it's called Untitled. You can see on the top left. So if we save it, I could save it. Empty level, for example. Right now we can see this is the empty level that we have in here. And these are all our actors in here, right? Once you take an asset from your content browser and you drag it in here, and that you can see it in the outliner, we then refer to this as an actor. So we're going to click this little magnifying glass. We could see this is where our level exists. Right, I could go to File, New Level. I could have another basic level. We could save this one, for example. Right now we could save this one again. Basic level, for example. And now, right, it comes with some default things like your lighting, a floor, and this level is kind of like your scene file. So if you are working on this, I don't know, bookstore, book in a cave environment, right, you will just import all your book assets here, your bookshelves, whatever, and then you're going to save this file, right? You're going to save this level. And then if another artist is working on this file in this environment, like a lighting artist, for example, they will also open this level to work from. Right, so a level contains assets similar to an outliner in Maya, for example, or like a scene hierarchy in Katana. Right, many artists will work on that same level. So it might be helpful for you to think of a level as like an environment asset or a layout assembly. And then also multiple levels can be grouped together, right? Grouped levels always live inside something called a persistent level, and levels that live inside of it are called sub-levels. So let's just take a look at that real quick. So I can go to window and I can open my levels panel. I'm going to dock it right here. And we can see we have something it's just called a persistent level, right? We know that our level is actually called basic level, but it's also considered a persistent level. Any level you open will be called a persistent level. But I could take our empty level, and if I drag it in here, now we can see we have an empty level here. So everything from our empty level is now combined with our basic level. And in an outliner, we could have a filter called see only in current level. If I uncheck that, then we could see all the assets that are in both of the levels, right? And then after that, we have to save our persistent level. So every time we open our basic level, our empty level is loaded as part of it. We could also open our empty level separately. Right now we see we don't have any sub-levels in here. But if we make any changes here, right, and save, because our basic level is referencing this empty level, right, then those changes will also be visible here. So this is pretty straightforward, but I hope it makes sense. And one last concept is that this style of level management is called level streaming. So Unreal Engine has another type of level management for open world games, and that's called world partition. We use either this empty level or this basic level as our starting points for creating levels in linear content, usually, unless your pipeline is designed otherwise. And world partition can kind of like divide your level into many different grids, so you could load huge open worlds. And usually for linear content, level streaming makes more sense because you could hide levels. You could pick what you want to see, what you don't want to see, much easier. Okay, so I hope that kind of makes sense, right? Just to recap, Unreal Engine project is a single file. Everyone works from that project, right? It's kind of like a scene file. It's a scene file that everyone uses. Levels are individual scene files that act more of like environment assets or layout assemblies. So a lighting artist will open this environment asset and render from it. A lighting artist, and an environment artist would be opening this level to add assets to it, for example. So next I want to talk about shots, right? In VFX, a shot is a code that defines a single camera cut in the film, right? It corresponds to a directory on disk where scene files and shot related assets are stored, right? And in traditional VFX, it's not really easy or quick, I'd say quick, to switch between shots or to view the entire sequence. So for example, I don't know, you have a sequence of two characters fighting, and it's pretty common to, load a scene file for one shot and work in it, and then when you're done, you load the next one. And it could take like 5 minutes to load a scene. If it's a huge scene, it could take 10 minutes or more, right? Like it depends on the pipeline and tools, but VFX workflows aren't really designed to work in context and in sequence, right? In Unreal Engine, the equivalent to a shot is something called a level sequence, right? So a level sequence is an actual asset that's tied to a level. And by tied, I mean you could use the same level sequence with another level. It might not work, but it's just possible. And I'll explain more. Right, the level sequence is usually named after shot code, right? And the level sequence has to contain the camera or the reference to it. So it might be helpful to think of the level that we just talked about as the scene file and the level sequence as the render camera, essentially, to render that scene file. And in Unreal, you could actually load all your shots at once in something called a parent sequence. So you could view all your shots in context and pretty much instantly in real time, right? So you can, I don't know, position your directional light, your sunlight in one shot and see how it works in a different shot immediately, right? So you're working in context. You could see the animation in context. You could see the edit in context. So this way of working is really, really fast, and I really, really enjoy it over kind of like the traditional VFX shot workflows. Okay, so let's jump into Unreal Engine, right? So if we right click in our content browser, here's how we could create a bunch of assets in here, right? So we could create the level sequence asset, right? Usually we'll name it level sequence, I don't know, shot A, for example. And then we could open it by double clicking on it, and we get the sequencer panel, right? So I'm just going to hide my empty level here. So we have our sequencer, and if we press this camera button, it will create a camera. So it created this camera actor, and we also have this camera cuts track. Things in sequencer are called tracks, right? And over here, you can actually see it says right here, Cine Camera Actor. And this track is called Cine Camera Actor, or camera. So this camera cuts track has a binding to this camera, right? I can have multiple cameras in this sequence, level sequence, but only one is actually tagged as the render camera, right? And this timeline represents our frame range. So if I'm looking through my Cine camera right now. I don't know if I position it right here to look at our characters, right? If I were to render this, that's the camera it would use, and this is the level I would use. So technically, it's possible to use the same level sequence because it's a separate asset with a different level. Now, of course, it probably won't work because, this camera is positioned to specifically work with this environment. Now, another important concept in Sequencer and Unreal Engine is the concept of possessable actors and spawnable actors. So these actors, they live in the level, right? But we could see that this Cine camera actor was created in Sequencer, but we also see it in our outliner. But here we have a little lightning bolt, and it says that it's part of a sequencer, right? Our sequence ls shot A. So that means that this is a spawnable actor. That means we're spawning it from Sequencer. Now, if I take my character and I drag it from the outliner into Sequencer, let's give it a second. So we could see it added it. It doesn't have a lightning bolt. It also took us into animation mode, but let's just leave that. So we could see that our sequencer outliner column is populated, but there's no lightning. So that means it's possessable. We're possessing an actor from the level. And in this level sequence, we could manipulate it. Right? We could, we could change, we could add animation to it, right? This is how we would add animation. So each different level sequence will use the same asset, for example, you could possess it and assign a different animation that's relevant to this shot, right? We could do overrides, like for materials, for example. We could create geometry here, right? Like maybe we have another one of these cylinders, right? I could drag it into sequencer. Now we have a spawnable cylinder, and this will only be relevant when we have this level sequence open. So if I close the sequencer window, right, boom, we can see that this extra cylinder we had here, it's gone. It disappeared, right? Because it's only relevant to that level sequence. So quick recap, level sequence. A level sequence is an asset in the content browser. The level sequence ls has a reference to the render camera, or it can spawn the render camera. It contains the shot start and length frames. It's open inside the sequencer window, which contains the timeline, your frame ranges, right? Similar to Premiere and Resolve, it has a timeline and tracks. And it contains assets like meshes that you're spawning, and it's kind of tied to a level. You need a level to render with it. Next, we're going to talk about rendering and playblasting, right? So rendering and playblasting is a very common thing to do in VFX, right? Renders are launched from a scene file in VFX to the farm or locally, usually to the farm because rendering takes a while. Scene files have render passes and quality settings usually kind of set up inside the scene file. So playblasting is kind of a new feature in Unreal. Usually you have to set up a level sequence and your level and your render settings and then render it. But now you are able to just kind of playblast what you see in your viewport in Unreal. But usually the actual rendering is done through something called the movie render queue, which is a window that sets up your level and level sequence and render settings and sends it to the farm. Right, rendering is extremely fast in Unreal. A frame could take seconds, depending on your quality and render settings. Render presets are created in something called the MRQ or the MRG, right? Movie render graph. Movie render graph is the new way of creating render settings in Unreal, and it's node-based. Before, the MRQ was kind of list-based. And I will demonstrate these visually soon, right? The MRQ window is, or MRQ job is a level sequence with a level associated with it. And in Unreal, what you see in the editor, right? By editor, I mean in the actual viewport, isn't always what you see in the render, right? There's different kind of render settings and console variables you might have to set up to kind of get what you're after sometimes. And this is a common kind of gripe with VFX artists transitioning to Unreal Engine for linear content creation. And this is slowly, getting a lot better, and you will learn with experience how to make the engine work for you, right? Because it is a game engine, and linear content creation with it is fairly new, right? Common AOVs are supported in Unreal Engine, but light groups are not, because Unreal Engine, even though it does have a path tracing engine, the actual render engine is, I think, is deferred rendering. And so because of the type of renderer Unreal is, it's hard to break apart lights into different AOVs and the indirect contribution. And render layers or render passes, right, are, like rendering the environment and characters in separate passes is possible in Unreal Engine, but sort of discouraged because it's not as efficient as just rendering everything in one pass and making everything look good, right? We're utilizing Unreal for speed, I guess. So that's why we want to aim for efficiency and speed over just reproducing the entire VFX workflow. At least this is my opinion. So back in Unreal Engine, in the window, cinematics, we go movie render queue. This is also a plugin. If you go to editor plugins and you type in movie render queue, here we see movie render queue, movie queue, additional render passes. You'll probably want this one on as well. And movie render graph is also part of this. So we could dock this panel, and if we click render, here we could select a list of sequences, right? So we select LS shot A. And here, when we select it, we could see our sequence again. So this is just a job here. This is just a job. You can see right here. This is our level sequence, and this is the level it's associated with, right? So you could select the level yourself. Maybe you didn't select the right. By default, it will add the level that you have open. So, and here we have settings. So by default, you could click on this, and this is the old way. This is a list of render settings here. We could add different ones like anti-aliasing, game overrides, things like that. That's kind of the old way of doing it. The movie render graph is in beta still, but here, if we click this drop down, we could click movie render graph, and it will show you this node-based menu, right? So by default, right, it says the default graph asset is being edited, save as, to use a new graph asset. So you'd want to duplicate this one so you don't override the default one. And here it's node based, and you could set up different render layers, right? So render passes, whichever one you want to call them. You want to, how are they exported as JPEG, EXR, etc. You could do filtering of assets in your level, like maybe everything that's has a tag of effects or certain name or certain sub level will go to a different render pass. And that's how you set up your render settings. And after that, you're just going to click render local, and this will render the this will render things locally for you. So what is actually rendering in Unreal Engine, right? So when you actually render something, your engine is going to click play, right? And this is called play in editor, right? So this is pretty much the same as running a game. If you were building a game in Unreal and you click play, then you could control your character, for example. But in linear content with sequencer, when we click play, it will just have our it will just instead of controlling a character, you're going to be tied to your camera. All right, so here is my animated camera, and I have a single character in here. So let's go and click play. Then I'm going to click Shift F1 just so I can get my cursor back so it's not locked to the game screen. So make sure that I'm clicking this button for camera cuts. And now when I scrub the timeline or play, we could see my camera animation, and we could see that we're also playing in game. Oh, it's going backwards. And we can see that this is playing in game. And if we were to render, this is pretty much what would come out. One other thing we want to take a look at is this begin render button. And then this is this quick render. This is pretty much what Playblasting is. And so by default, right, it's set to quick render, which is kind of like a play blast, but it also says the current sequence, or you could do use viewport camera in sequence, or current viewport, or selected cameras, right? So you have a couple of different options for what camera to use, right? Instead of selecting them in the camera sequencer, right? Making sure that the binding is set correctly. In here, we can choose which camera you want. So let's try current view still. You see it's just a still frame, a single frame render. Let's see, use viewport camera. There we go. Viewport cameras, you know, it's not playing our animation either, right? So I'm just gonna, oh, it's so quick. See. And we could also, you know, play last render, open output directory, and there's some settings we can adjust if we want. And that is pretty much it. Nice and simple, just giving you kind of the main concepts that you will need if you're transferring from kind of the traditional VFX workflows to real-time workflows. Hopefully you can use that information to quickly bridge those basic gaps and start creating and start learning, exploring, and figuring out all the other fun stuff, so you could use real-time technologies. Thank you for watching, and I will see you later. Bye.